Hey everyone, this is your key for your uniform motion study guide. And the first question that you guys have is, what do all of these symbols mean? If you know the simple stuff, that makes it pretty easy. Remember that the delta sign always means change, and X always means position, and T is always representing time. If you know all of that stuff, then everything else is pretty easy. So let's go ahead and get these filled out. So here we have everything filled out, and everything's pretty cut and dry up until you get to this very bottom one. This is the same symbol for change in position, but it has these bars around it, the absolute value bars. Absolute value bars always mean that whatever it is inside the bars must be changed to a positive all the time. So anything with absolute value bars means that it is never negative. And the only thing that we've talked about that is never negative is distance, because distance doesn't matter which direction you move, it only matters how far you moved. So distance is never negative, which is why you need to remember that for the absolute value bars. Question number 2 talks about defining uniform motion, which also means traveling at a constant speed, using the terms distance and time interval. And then it says you can draw a picture. So what I've done is I've tried to describe it by using a picture. So imagine your Play-Doh discs from the battery car. What's important is that for every time interval, so you could say this is 2 seconds, 4 seconds, 6 seconds, 8, 10, so on and so forth, you have an equal distance between the Play-Doh discs. So constant speed, using these terms, is that the object will travel an equal distance per time interval. Question number 3 wants you to write the formula for change in position. We've talked about this many times. Change in position is this. We know that that means change and that means position. And so what you want to do is take the final or end minus the initial or start. Number 4, the position of an object can only be defined relative to another object or mark or specified 0 position. We measured both the bubble lab and the battery car lab from a 0 position, so don't forget about that. Number 5, defining distance and write the formula to calculate distance. Distance is simply how far something has traveled. Doesn't matter the direction. Now, the formula, just remember, absolute value bars. We talked about that up above there. So absolute value bars, other than that, it's the same as change in position. Distance can never be negative because of these bars. On this page, number 6, the major difference between distance and change in position, been talking about it the last couple of times. Distance is only how far, doesn't include direction, so it can't be negative. Change in position definitely requires a direction. Did it change position 5 meters this way or 5 meters this way? So this one cannot be negative, but this one definitely can. So for these problems, we're going to use what we just wrote down in the previous questions. It says the front end of the faded car is the position at initial time. So the faded car front end is right there, which would be at 16 kilometers. That's your XI, don't forget units. Front end of the solid car is the position at the final time. So right there it is at 5 kilometers. The mathematical expression for change in position or distance is always the same. XF minus XI every time. So then you just sub it in. 5 minus 16. This is going to be negative 11 kilometers. But distance has those absolute value bars. Very important. So it can never be negative, so it's just 11. So using what we just went through up above here, I'm just going to quickly write down what I got on this one, and you can see if you're right. So here we go. This is what I got for this number 7, the second part. Remember that when you subtract a negative, that means you're supposed to add. So now we're doing the change in position between clock tick 3 and clock tick 5. First thing you gotta notice is you're looking for change in position, so that means that you're gonna follow this formula. So we have tick 3 and tick 5, that's gonna be XF, that's gonna be XI, this is where we start, this is where we finish. So then you just find the position at those places. So tick number 5, follow it up, it's right here. So then I follow that all the way over, and I'm at 12. I go to clock tick number 3, follow it up and over, so I'm at 8. Then I just sub in my numbers. 12 minus 8 gives me a change in position of 4. And then I looked at my units up here. It's not meters, it is centimeters. So then it says we want the vertical intercept of the graph. Vertical is up and down this way, so we're talking about this axis of the graph. And intercept means where your line intersects it. So this line comes and touches my vertical axis right there. So my vertical intercept has to be 2 centimeters. And then it says, what do you think it means? Well, here's 0, but my car never started there. It started clear up here at 2. So it means that my car didn't start at 0, it started 2 centimeters ahead of 0. So now we're calculating the slope of each line. So the first thing that you ask yourself is, does the graph start at 0 or not? In this case, all of these graphs are starting at 0, which means that your formula that you want to use is rise over run. You use rise over run for graphs that start at 0. So if I was going to do the slope of this graph, I would find a point where it goes right through a corner like this. And so I'm going to do my rise first, which is how much it rose from 0. So over here it rose 80 over how much it ran from 0. And it ran here. I just follow this down to the 20. So 80 divided by 20 gives you 4. And then check your units. There's the ones for the rise. And there's the ones for the run. So 4 meters per second. It should come out as a speed because slope represents speed. If it's medium like this, it's a medium speed. If it's steeper like this, then it's going to be fast, and if it's low like this, it's going to be a slow speed. So always have a unit that represents speed for slope. And on these, it doesn't matter if I would have picked this point or this point or this point, it doesn't matter. You can pick any point that you want as long as it goes through a good intersection, and it'll work out just the same. So I'm going to fill out the rest of these and you can see if you got them right. So here we go. This is what you should have gotten on all your slopes using rise over run. So on this one, it says to calculate the speed. Well, we just talked about this. Slope represents the speed of the object, so it's really asking you to calculate slope. Graph starts from 0 again, so just pick a good intersection, like this right here. Rise over run. So my slope is 0.5, but it is a speed, so my units are kilometers over hours. Position at 3 hours, I go here, up and find my line, follow it over to where I find my position. So there's going to be 1.5 kilometers, and it's a position, so it's from 0. Position at 2 hours, follow it up, over, 1 kilometer from 0. Position at 1 hour 20 minutes. On this one, 1 hour is 60 minutes. So if I want to divide 60 by 3, I'll know how many minutes I'm going by. 60 divided by 3 is 20, so I know each line is 20 minutes. So to get to 1 hour, 20 minutes, I would be at this line, follow it up, and over, and it looks like I'm just below the 0.75 mark. So I'm going to put it at about 0.70. Okay, do not forget, you have to write positions from a 0 point. So here we're talking about how far from his starting point, so we're talking about Andy, was he at t equals 5 seconds? Well, first thing you need to figure out is where his starting point was. So go up here, and at time 0, Andy was at about 10 meters. And then at 5 seconds, he was, follow it up, it's like this. At 5 seconds, he was at about 20. Maybe 21. I'm going to just leave it at 20 meters. And then how far was he? Final minus initial gives me 10 meters. How do I know? Looked at my graph and found xf and xi. Was his speed constant? Looks like a straight line to me, so yes. And then it says, what was the speed? So again, it's asking you to do slope. So ask yourself, does this start at 0? No, it does not. So you have to use your other slope equation, which looks like this. And you sub it in. You're going to use the final point and the initial point. Using those points, I see that at final position and final time, he was at 30 and 10. At initial position and initial time, he was at 10 and 0. So then I just subtract it, and that gives me his speed, which is in meters per second. So there we go. Letter C says Robin was further along at 2 seconds than Andy was. Does that mean she was going faster? So let's take a look at these. This one looks to be a little bit steeper. So at 2 seconds, let's think about it this way. We do a graph here and a graph here. So we could have 2 lines going relatively the same steepness. One could go like this, and the other could go like this. This person would still be ahead at 2 seconds, but the problem was they didn't start clear back here at 0. They kind of cheated and started up here. So no, it doesn't mean she was going faster. So explaining your answer, maybe she didn't start at 0. So now we have to make a good graph. First thing you always want to do is put a title. I've already done it. It's just something you have to do. The position and time axis is already labeled, so all we have to do is make sure that it has units. So for my position, I look over here and it's in centimeters, so I'm just going to write that right there next to it. For my time, it's in seconds, so I'm just going to write that right there next to it. For this axis right here, it looks like the top thing that I need to get to is 53. And so if I take 53 divided by the 10 lines, that gives me 5.3. And you always want to round up to the next number. So if I get 5.3 when I divide, I'd want to go by 6s. So I would go by 6s all the way up. So I've gone by 6s all the way up through here. As you can see, I went by 6s the whole way. I can't go from here up to 3 and then to 8 and then to 13, because that puts a different amount of numbers between each block, and the blocks are the same amount of space, so I have to go same scale all the way up. I added my scale by ones along the time axis and I plotted my points. So the next thing that's very important is to use a straight edge to draw a line through my dots. So now my graph is perfect, so I can start answering the questions. Initial position is where they started, so you can either go to time 0 and look, or it's much easier to go over here, go to time 0, that's where he was. 3 centimeters. What type of motion is represented? It's a straight line, so I know it's constant speed. The slope of the line. Looking at it again, we can't use rise over run because it doesn't start at 0. So we have to go back and use this equation right here. So finding XF and TF, go to your final time here and your final position. So just fill them in, 53 over 10. And then your initial time and initial position here, 3 and 0. So that gives me 50 over 10, which means it goes 5 centimeters per second. Remember to take a look back at your units to make sure that you get them right. And last we have our speed, distance, and time word problems. So just remember, point out what you're given and then use your triangle, this right here, to help you know what to do to solve. So here, 400 meters is a distance, 20 seconds is a time, so that means I'm looking for speed. So I cover that up on my triangle and it tells me I should do distance divided by time. So I would just write that right there, do my 400 divided by 20, and then of course I don't want to leave it as a fraction, so I would solve, giving me 20. And this is a speed, so that means I'm going to need a unit of distance over a unit of time. And I'd be done. So you guys can take a look at how I did all of these on this page and take a look back at your graded papers. That'd be a good way for you to study. So here's a look at the first few problems. I went ahead and marked everything that I was given, wrote down the equation that I was supposed to use, set it up, solved, and made sure that my units made sense. This one asks me how much time. Seconds make sense. Meters per second and meters don't make sense for how much time something takes. Here are your last 3 problems. So make sure you not only got the answer right, but you got the units right. And use this to study for your test on Friday. And you can find lots of practice problems and stuff online. I'll be here before school if you have any questions. Good luck, everybody.